Well, hello, everybody. Mike with Spray Jones coming to you with part two of our fake news series on spray foam insulation. Previous one, we covered off whether or not you should be comparing the R value that you get in spray foam insulation to the R value that you're going to get with a fibrous product. This one, we're going to get into the quote-unquote questionable claims of air sealing abilities with spray foam. So what I have seen on the internet, not just through one individual or even two, I've seen it on multiples with people that have done, Instagram shorts or YouTube shorts or what have you, just all over the globe. People have said that the spray foam at best is questionable. It's unreliable as an air sealing product. There's been people that have said straight up, you can't depend on this. There's been a number of people, the first thing that ever was said to me when I sat down with a builder was, what happens if it breaks away from the studs? There's a lot of people that claim that spray foam is not a standalone product, that exterior wrap and interior air films should be used. And then the more erroneous things are that spray foam can be absolutely worse than bats, and that the buildings will test out in a horrible state. And I suppose in the annals of failure, if you want something to fail and fail bad, yeah, you could probably get something to fail pretty doggone horrible. But to put it up against fibrous materials, you'd have to really quantify that. So let's get into this on fake news. Is spray foam, at best, is it questionable, and is it unreliable in its air sealing abilities? Well, I'm going to take you to a report here, Journal of Building Physics. This report was done on 2012, and it's an air infiltration through building envelopes review. Now, this is a lengthy 37-page document. It's got just a lot of nerdy stuff where they study and study and study all of these things. So I've gone through and read this a couple of times. And it's good. It's all right. It's just not going to be my nighttime reading. And I'm going to skip us down to page 13. All right, here we go. Air change methods, empirical techniques. The air change method depends on a tabulation of average air changes per hour, as shown in Table 3. The values in such tables are based on construction tightness. The tightness of construction depends largely on workmanship. Typically, residential construction falls in the low end to medium end category. And here's something that they could talk about. In order for you to be tight, you're getting 0.2 to 0.6 air change per hour. 0.6 to 1 air change per hour is medium, and then loose is 1 to 2. We had a program in Canada where they were certifying homes to be not Energy Star, but like one down from Energy Star type of thing. The Energy Star program was a big one. It involved water and power and lights and low flow toilets and all this sort of stuff, but it also involved air leakage. And at that time, to get your what is it called? R1000, R2000 certification in Canada. To get your R2000 certification, you needed to be 1.5 air change per hour or less, and that was with the drywall off, right? So you get the house all batted, and then you would get it inspected, which is going to be very, very important here as we get into this. So construction methods, what you're using, the gaps, and then how you're going to install to seal the building up is very, very important. And I don't think it would be at all intellectually favorable or fair to blame any one product. Rigid on the outside, bats. I mean, there's certain products which are going to be inherently difficult to get things sealed up. We would all agree that the building, wood frame or commercial construction, let's just stay with wood frame construction right now. So you're going to have studs, you're going to have plywood sheeting, you're going to have some sort of a wrap of some sort, your exterior sheeting. it's going to be very difficult to get that thing sealed up with conventional sheet products. There's lots of gaps, and that's the next thing that I want to go to here. Is this report on the next page talks about the types of air infiltration. So here we go. Diffuse air infiltration. Air infiltration occurs through minute cracks and paths in the walls and the overall building envelope. Okay, that's agreed. In diffused infiltration, in contrast with concentrated infiltration, so concentrated air infiltration is windows and doors and large gaps, right? So weather stripping and air seals and large openings, right? That's concentrated air infiltration. Infiltrating air travels through the wall for several feet before reaching the interior, right? The air infiltration through cracks surrounding doors and windows is classified as concentrated infiltration. Even though the air is infiltrating through small openings and cracks, it does not travel by a relatively long distance in the wall, and therefore this infiltration is considered concentrated and not diffused. Diffused air leakage, diffused leakage of air through a wall shifts, this is the important part, shifts the temperature distribution of the wall from straight line distribution to a curved distribution. A heat exchange occurs between the wall and the infiltrating air, a phenomenon known as heat recovery. Heat recovery plays a significant role in evaluating the heating and cooling loads due to air leakage. Boom. All right. Why have I taken the opening 6 minutes, almost 7 minutes of the video to explain these two things to you? One, so workmanship on what you've chosen and what you choose, how the building is constructed, the gaps that the building has to begin with, and then the products that you use to seal those gaps up is going to have a huge bearing on just exactly how well everything's going to work. Two types of air infiltration that we're dealing with. We're dealing with diffused air, which is far more detrimental in the structure. So if you are going to have batted fibrous insulations, whether it's blown in cellulose, whether it's sprayed in fiberglass, such as a spider wall system or a bib system, or you're going to do mineral fiber batting, whatever. If you're going to do some sort of, let's just call it very open cell fibrous material in the wall assembly, you're going to have this death by 1,000 cuts is what I call it. So you are dealing with pulling down the overall efficiency of the wall assembly through diffused air infiltration because the air is coming in through all these multiple little cracks. So right off the bat, open cell foam and closed cell foam are going to kick the pants off of these products because the only opportunity that you've got is to deal with some sort of air barrier to the outside. Now you should. Let's be clear. The outside of your building needs to have a wrap. It needs to be protected from the wind and from the rain, and it needs to be something behind the exterior siding. I agree with Matt Reisinger that the home should be basically airtight and watertight to the exterior before you start doing anything on the inside. So talking about whether or not using closed cell or open cell spray foam insulation in the walls does not exempt you from doing one heck of a great job of sealing the building up on the exterior. In fact, we're going to get into that on another video when we talk about roofs and talk about walls. We're going to talk about water flow and water damage and, you know, are we sealing the buildings up too tight? And how do we deal with moisture? So you have got to have a watertight, airtight building to the exterior. But even still, all right, I still want to put a non-permeable product in between the studs. So I do not want something that if my primary source on the outside is compromised, that I then have no secondary protection. And let's be honest, most people are not putting a high airtight, watertight layer on the outside. They're going to be putting some type of a house wrap. They're going to staple it on. It's going to be in the wind. It's going to be done with tape. It's going to be flapping, ripping. You know, they just put this up very, very quickly because it's weather dependent to get it on, and then you're trying to get it covered. There's not a whole heck of a lot of trial to get a high level of air seal. Now, there are contractors out there that can do it and will do it. I'm saying that the average home with the average workmanship, it is not well sealed. So your primary first, well, not even primary, but your first line of defense to the exterior is compromised to some degree due to time of the year, installation methods, and the diligence of the contractor and the materials that you've chosen. All right, so what does that happen to do with the wall? Well, we still want a primary air seal, air leakage product in between the walls. We still do not want to rely on a film on the exterior, right? We want to put something that is going to be in tight, intimate contact, bonded to the stud, to the exterior sheeting, that air does not go through, and preferably also water. It's water impervious. So right away, off the bat, spray foam is it. That is going to be the product that we're looking for. We do not want to allow these small amount of air leakage inside of the wall, traveling laterally for a couple of feet, up, down, or otherwise, before they make it to the interior side. We want to stop that. Never mention, or not to mention, the convective loop that happens inside of insulations. There's a convective loop where you've got warm air rising against the sheeting, right, or the drywall, and you've got cold, dense air falling, and you can get a convective loop within the insulation itself, even when you don't have external infiltration. Now, let's take a look at a very, very telling air leakage report. Okay, so I've used this many times before. We've done this in the vapor barrier. Is a spray foam a vapor barrier? And talking about vapor barriers. And this is the National Research Council's official study for a wall energy rating system. And they built 2x6 walls, 60 non-center spacings, and then they had them sprayed with closed cell foam and batting. Now, I just want to scroll down to keep things moving in the conversation here. It had a weather-resistant weather barrier on the outside, had poly on the inside, no cladding to the outside, 2.5 meter by 2.5 meter wall assembly. Here we'll go to what it looks like. 2x6 wall, right? So we've got OSB sheeting, 11 millimeters. We've got the insulation. We've got a vapor barrier. They've got the sheetrock on the inside, and then what they've done is they've marked out the studs and they've spaced out the screws on the wall every 8 inches. So they've not missed a single stud, right? So they have gone the absolute perfect theoretical fiberglass batted wall. Now, when we come to our air leakage test report, this is mind-blowing. So this is the maximum allowable limit in Canada for air leakage, 0.05 liters per square meter, right? Now, the other video I was talking about open cell foam, and I'm going to switch screens here. And I'm going to zoom right in here. And this is open cell. This isn't even closed. Here is the air leakage at 3 inches. Air permeance at 3 inches thick. ASTM, standardized test. 0.014 liters per square meter. And what's the maximum allowable limit? 0.05. So already, using an open cell foam, you are underneath the maximum allowable limit of air leakage. 0.014 compared to 0.05. This is the very standard that we have in Canada that mandates what we call an AVB, air vapor barrier. So in Canada, you have to have because of the cold climate, you have to have a continuous air barrier on the interior side. So that means we put poly between plates, interior to exterior walls, all of the trusses, the roof plates, everything. There is a continuous air film, and then the batten poly guys tape and caulk and staple into those flaps so that there's actual air or an air film between the plates, that they're not just solely relying on caulking. When they tested out this wall assembly, this is a fiberglass batted wall without penetrations. So here's the wall here. Okay, here's your maximum allowable limit. And where are we at here? We're at 0.45, 0.46, 0.4. So we are way in the heck. We're 400%. 400% more air leakage greater than the standard. And that's without penetration, so no wall plugs. When they bat the wall and put plugs in, the factor goes up to over 600%. So with penetrations, with wall plugs, your air leakage rate on a 2x6 batted wall is 600% greater than the maximum allowable limit. And here's the spray foam walls, right? They are not exceeding the maximum allowable limits. So they're underneath this mark right here is where we're at 0.05. I do not know how anybody is going to claim that the spray foam as a product cannot air seal when that's exactly what it's designed to do. We take a look at closed cell foam right here. This is the V5, available in multiple grades. Superior thermal resistance, excellent air sealing ability. V5 is intended for residential, commercial, and institutional buildings where insulation is required. So in Canada, we've got the testing for an insulation, vapor control, and air control. Now, to be fair, if you go and put spray closed cell foam or open cell foam between the studs, and then that's all you do, it is going to be a failure. Because the next weakest link is the wood-to-wood joints. So where is the air leakage going to be? It's going to be at the plates, it's going to be at the headers, it's going to be at the corners, it's going to be at all of the connection points. In fact, let's go to a picture. Right here we've got a 2x6 wall with closed cell foam, wall type. We'll zoom in a little bit closer here. 3 inches of wall type. But what is it showing you? It's showing you that all of the studs, the doubles, the triples, the plates, the connections, all of it needs to be caulked and sealed. Because you're trying to have everything work as an assembly. You can't get any air to go through the foam. The foam is bonded and tested. Like the foam has an adhesion standard to the wood. So if it's failing the adhesion standard, it's going to fail elsewhere. So that comes down to installation. We're going to cover that in another video. Adhesion, co-adhesion, sticking to itself. So if the wood is going to be warm, the wood's going to be dry, it's going to stick and stick tenaciously. It's also going to stick to the studs. It wouldn't get an air leakage rating. How could we test for air leakage if the spray foam continuously let go of the studs and let go of the wood just on its own? Chemically, it's bonded to it, right? It's also got mechanical adhesion. But then all of the connection points of the plates and all the areas where you can't put spray foam, that's where you're going to be using your can foam and you're going to be using your caulking and your sealants. And this is a highly critical part that very few spray foam guys have yet to fully grasp. And I don't care if you're in Texas or Alaska or in the rest of Canada, you need to be doing caulking at your seams. It doesn't matter if it's warm outside and you're using air conditioning. You want to control air leakage. You want to stop the diffusion going through the walls. The spray foam is going to take care of all the micro cracks, and then the major cracks where you can actually see daylight coming through some of these seams, that's where it needs to be caulked and air sealed. So you're not relying on plastic on the interior side. In fact, we've just seen that you can't rely on plastic. The previous report that we just looked at showed that as soon as you go and punch holes through it, the air leakage is 400%, and when you get penetrations, it's 600% more air leakage. That's non-debatable. So is the spray foam the way to go? Yeah, because what I tell people all the time when they're asking questions about foam and air sealing is that your vapor control and your air barrier control is not single plane. It's now 3 or 4 inches thick. Right? It's not reliant on one little thin film that you punch a hole through or it tears, right, on the outside of the building or the inside of the building. So the entire assembly becomes the point of resistance, where you got the foam between the studs, you got the caulking to finish it up, and we use really good tenacious products that are designed for air sealing. Why on earth, if this wasn't important, is Johns Manville and Owens Corning not going around and advocating for the internal air seal of products? Like, why not? Why are they having you use air seal on all the joints? They're trying to stop the micro diffusion coming in through the walls before it gets through the bat. So the fibrous materials can't stop this from happening. You need something adhered. It needs to be liquid applied, adhered, like something like a caulking or a can foam. Well, at that point, why not just spray the principal insulation Why not spray the foam insulation in between the walls? So if the walls are clean, the walls are dry, it's going to stick. When it sticks, it's going to stop the air. Where's the air next going to try to go through? The seams. What do you do with the seams? They get caulked, they get air sealed, right? Can foam around the windows, can foam the little bigger cracks that you can't get the spray foam gun into. So the whole entire assembly becomes one working piece. And then we've had our homes air sealed tested, and we've gotten 0.8 air changes per hour before the sheetrock is ever put on. So no, the spray foam does not need to depend on something else. The sealing abilities of the foam are not questionable. They're verifiable. We've got laboratory results on it. It's an actual air seal and vapor control product, vapor barrier, and we'll get into that in the next video when we're doing vapor barriers. So I know this is a little bit longer video, but you need to knock down these fake claims that the product cannot air seal. I mean, we're putting this on the exterior of buildings. We're putting it on the interior buildings with architects and engineers. It's going on hospitals and museums and you name it. Banks, schools, all the time. And they're calling for, in many cases, they can't even achieve air seal capabilities with membrane. They need some sort of a liquid applied foam into place. The number one reason that foam insulation is such a great product is because it rises and then it sets. But you've got to get it in. If you miss a spot, no, it's not going to be air sealed. But then that's not the fault of the foam, is it? Because it doesn't work in the truck. It doesn't work in the parking lot. It doesn't work on the floor inside the house. It's got to work where you place it. It's got to work where it's needed, right? So where the gaps are, you've got to place the foam. And that's on the installer, and we'll cover that in the installation video. So this one's long enough. If you've stuck around, thank you. But we're knocking down these lies like bowling pins. The spray foam is totally capable of air sealing. You just got to have somebody that knows and understands what they're doing. And if you guys are watching my video that are spray foam guys and you've stayed this long, make sure you start telling your clients about this. Make sure you start doing this with you and your people. Air seal is very, very important. You've got to get the foam into the cracks and into the crevices and into the corners. Nobody's paying you to just paint the easy areas. Got to do the difficult spots. All right, share, like, and subscribe. Leave a comment. I really want to hear what you guys have to say. You'll see me in the comments, firing back, booting the people out of there that don't need to be too. So share, like, and subscribe. I'll catch you on the next one. There's more to go. Bye.